Hello and welcome to C# 101 Week 6. My name is Nelson and I'm going to be here today. So last week we went through some odds and ends in the C# language that I wanted to cover in this class, but they didn't really fit into any particular class. And I did that last week because this week is going to be very difficult. It's going to be a very new way of thinking to a lot of people here. And I wanted to give people sort of a little break before we delved into something that's going to be fairly complex. So last week we covered things like basic exception handling, debugging, enumerations, and so on. So again, just a quick week, low stress to cover some odds and ends about C# that I wanted to cover before we got to this week. Because this week we are going to be talking about object-oriented programming. So I'm sure a lot of you guys have heard the term object-oriented programming, which is commonly abbreviated as OOP, mainly because, whenever you hear a description of the C# language itself, you'll hear that C# is an object-oriented programming language. What exactly does that mean? Well, object-oriented programming is a programming paradigm, and a paradigm is really just a way of thinking, a way of solving particular programming challenges. I want to make it very clear right now that although C# is an object-oriented programming language, it doesn't necessarily mean that all C# code you write is going to be object-oriented in design. And it also means that languages that aren't object-oriented, such as, well, C, aren't necessarily going to make it so you can't write object-oriented code. So I want to make that distinction very clear, that although C# has features that make OOP easier to program for, it doesn't mean you have to use them. And it doesn't mean that if you're in a language you can't still take the same concepts of what makes an object-oriented program and use them. So object-oriented programming is all about the concept of objects. It should sound fairly redundant because it's in the name. And an object is really just a way to encapsulate logic and data. We've actually seen quite a few examples of objects already. And pretty much every single variable that we've created in C# is an object. So if I were to, for example, have an integer and call this my int and say int equals 10, I could also do something like console writeline my int dot toString, for example. Although this is redundant in this case, what I'm trying to demonstrate here is that whenever we see this dot notation, we know that we are accessing a thing on an object. Maybe a better example, albeit slightly more complex, would be the list class. So we've seen examples of lists where we can have like a string list and we instantiate it, and then we go string list dot add whoa. And then we can say console writeline string list dot count, and then put in a console read key. I'm also going to toss in another list. How about a list of ints called int list equals new list of int list dot add, and then let's add like 10, 20, and 30. What do you guys think this program is going to output? So we get a lot of ones, and that's exactly what it's going to do. We get a lot of ones because we are, again, using the dot notation to access something on the string list. We're not accessing any data on the int list. What we have here is an example of quite a few object-oriented techniques. And the first thing to note is that we get, I'll prove it to you guys if you guys want, we get one. We get one because we are accessing a member or a thing on the string list, which contains its own data. We also created an int list and added 3 items to it, but when we go to print its count, we're not accessing the int list. I know what I'm saying here might sound very trivial, but we have a very good example up here of the concept of an object and an object containing data, and that object's data is isolated from other objects. So, what are objects? Right here on line 11, we have an example of an object. Right here on line 14, we have an example of an object. Like I said before, every variable you create in C# is technically an object. Now, there are differences between different kinds of objects, but that isn't important right now. What's important to understand is that an object is essentially a variable. Now, this isn't necessarily true for all programming languages, but it is true for C#, which makes describing this sort of stuff a lot easier. So we see an example right here of what constitutes an object, because we have an object right here, int list, line 14, and we have an example of us invoking methods directly on that object. Line 15, 16, and 17, we invoke the add method on the int list object. So that is an example of a behavior that is programmed into any object that has the type of list. We also see another example of some behavior we have on the list objects. Right here in line 19, we do .count. Now, .count is a bit of data that we are retrieving from the object. So, on this on what we're looking at, we are seeing an example of being able to invoke behavior on an object, and we're also seeing an example of being able to retrieve data from an object. So an object is nothing more than a bag of data and associated behavior. Just like a car, anything in the real world is really those two things. A car is nothing more than a behavior and data. So what I'm going to do right now is I'm going to toss an example up of using an object, or not using an object, but creating our own kinds of objects. We actually saw an example of creating our own kind of objects last week when we made enumerations. Remember what an enumeration is? It is a user-defined, well, not necessarily user-defined, but we can, as a programmer, be the user and define enumerations, which are types. But enumerations aren't the only kinds of types that we as a programmer can describe to C#. We also have classes. So we haven't really said much of anything about classes other than the fact that we have one right here in line 7, but we haven't really described what it does. And we've also said, I've been trying to throw out the terminology when talking about things like list. A list is a class. I can prove that to you by hovering over it. And unfortunately, it looks like Visual Studio's IntelliSense doesn't actually have the keyword class anywhere in the pop-up menu, so that's kind of disappointing. But still, list is a class. If you don't believe me, look it up on MSDN. So let's go ahead and talk about how we can create our own classes. I'm going to toss the syntax up here on the screen just to give people a perspective of where we're going with this. If you don't understand the syntax right now, that's fine. Just look at the characters that I'm typing out and know that we will be going over everything character by character. To set up this example, recall that in the previous class we had a list of string with product names with a list of, I think decimals, product prices. You guys remember this, right? Where we have product names and product prices, which are two lists. The only relationship between these two lists are the fact that we would add the same amount of items to product names and product prices and then associate them by having the two things happen to have the same index. Well, this is actually a problem, and it's a problem that classes and object-oriented programming can solve for us. So I'm going to rewrite this example. after I added product. So product 1 and product prices add blah. Okay, so this is fairly poor code. It's poor code because we have two objects that sort of represent the same sort of data that's related, but they aren't actually related in any way to themselves. So let's create another class. Now, this isn't the best way to define a class, but it is the simplest bit of syntax that I can use at the point to demonstrate what I'm talking about. So instead of having two lists of product names and product prices, right now I can do something quite amazing. I can make a list of product. And then I can create a product, set its values, and add it to the list. And I can do this over and over and over again. However many times I want. I'll finalize this example with a for each loop that will print out all of my products. Alrighty, so how many people's minds did I just blow? What we have here is an example of a custom class. A class is a special kind of type. And I say that because last week we talked about enumerations being a special kind of type. A class allows us to define a template for objects that we are allowed to create. Which means by using classes, we can create our own custom objects to behave in the way that makes sense for our program. Now you might be asking right now, well, how do you decide what thing should be turned into a class and what kind of behavior should go on the class and so on and so on? And that is a very, very big topic. It's called object-oriented design, and it's not something that is going to come very quickly. All I'm doing right now is showing you guys a tool that you can use to organize your programs in a way that makes your code better. And understanding how to use these tools will definitely come in time as you work with programming. So, again, a class is a special kind of type. Well, what do types allow us to do? Types allow us to create variables of something. Because a class is a special kind of type, we can now create variables of our new class that I defined on line 7. I defined a product class. So what does this code up here do between line 7 and 11? Well, it actually doesn't really do anything. We have a definition. Just like if I were to define an enumeration of, I don't know, enumeration of product type, soda, bread, I don't know, cheese. Just like if I was to define an enumeration, up here on line 13, this code doesn't do anything either. It doesn't do anything in the sense that nothing executes by just having this code in. Instead, what I've done is I now allowed my program to be able to create objects of type product. I can now create product objects. A class is nothing more than a template or a blueprint of a kind of object that you want to create. Now, this isn't true for all languages. If you come from other languages that are very loose, like JavaScript or PHP or whatever, you might be thinking that, well, I can just, create objects and do whatever I want with those objects. In C#, that isn't the case. In C#, you have to explicitly define the template of a object before you can use an object. And right here what I've done is I've created a template for product objects, and I've called it product, and it is a class. Remember, classes are a template that define what kind of object or how that object behaves when I create it. So if I click on the word product, Visual Studio highlights every instance that this type is used in my program, and we see quite a few of them. The first one is I create a list of product. Now the list of product behaves just like a list of int or a list of string, except for the type of data that this list contains is now a user-defined class. Now you'll see another example of a product. Notice right here on line 19, I instantiate a product. What happens right here? Well, what happens here on line 19 is I create a new object, and I'm naming that object product1. But most importantly, I'm giving the type of the object, I'm telling the type of the object to be product, and I'm telling the value of product1 to be a new instantiation of a product object. So, in this case, I am using the blueprint. This is executable code. Whereas a blueprint in itself doesn't do anything until you manufacture something with the blueprint. A class doesn't do anything until you instantiate an object using that blueprint. You can sort of think of it like, if I have the plans to build a car, that's not going to make a car magically appear. But once I have those plans in my hand, I can then create concrete cars, and as many of them as I want until I run out of resources. And the same is true with classes. We create a class up here. It doesn't do anything, but it does allow me at some point later on down the road in my program to create specific objects of that type. So that's great. We've instantiated an object, or we've instantiated a class, which makes it turn into an object. And then we do something special here on line 20 and 21. We use this little dot notation. Now the dot notation is something that you are going to be using quite a bit of in C#, and we've already seen lots of examples of it, particularly with other objects that we have, such as lists. The dot notation allows us to access what are called members of an object. When you instantiate an object from a class, you get an object back that has members. And those members are going to be the same things that are defined in your class definition. Which means that I could not do product1 dot blah 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 equals whoa and hey, nor could I do product1 dot price equals this is not a decimal. Both of these lines of code are invalid. They're invalid because the object I created was created from a class that, one, does not have a blah 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 member, and two, does have a price member, but the price member has a type of decimal. So what we are doing is basically creating a bucket of variables and stuffing them into a single variable. Kind of like a list, but we're giving them names. We have a name, which is a string. Now, notice how when I click on this identifier, Visual Studio highlights all the instances of this identifier. This tool that I've pointed out quite a few times in Visual Studio is very important to start to solidify people's mental model of how code works. Because when I click on name, we get a highlight up here on the definition of name on line 9. And we also get a highlight here on line 35 and 29 as usages of, or usages? That sounds like a really dumb word, but I'm pretty sure it's the right one. Anyway, we get also the usage of this identifier on line 29 and 35 highlighted. Okay, so just to recap, a class, well, let's back up. Object-oriented programming is all about constructing our programs using objects. In C#, objects come from types. One of those types is a class. We can create our own classes, however many we want in our program, and give them whatever data and behavior that we want. But that doesn't do anything until we instantiate the class and turn it into an object, and then we can use it. One of the things that's very important to understand about this code is that product 1 and product 2 are both created from the same blueprint, but they are not the same object. Just like if you had two cars that were created from the same plans, they might look the exact same in every regard, but if you break the window of one car, the window of the other car isn't going to break. You know, that'd be silly. And the same thing is true for object-oriented programming. Product 1 and product 2 are completely two separate objects, and they have their own behavior and they have their own data. Okay, let's see an example of adding behavior. Again, I'm not spending a whole lot of time on the syntax of a class right now for a reason. I want people to see an example of a relatively complete class, just to kind of have that steep in your guys' brains for a little bit, and then I'll talk about the syntax. So right now, our product has two bits of data. He has a name and a price. But he also has behavior, or can potentially have behavior, I should say. For example, if I wanted to, let's do this. Console write line, product list 1. And then I'm going to copy and paste this for each loop and say product list 2. And between product list 1 and product list 2, I'm going to instantiate a new product. And I'm going to give product 3 a name of product 3. And I'm going to give it a price of some arbitrary decimal. And then I'm going to add it to products. Okay, so now I'm going to hit F5. That's kind of ugly. Blah, 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 blah. There we go. Now I'm going to hit F5, and we have some code, and the code is executing, and it's giving us some output. The output it's giving us is the first listing of product gives us 2 products, and the second listing of products gives us 3 products. So that's awesome. What's wrong with this code? Can anybody see something that's potentially not so good about this code? Right, we have duplicate code. Now, we do have duplicate code in the sense of this for each loop, but I'm not going to focus on that right now. What I'm going to focus on is the duplicate code within lines 32 and 44. Imagine that you were going into your program and you wanted to change the way that products are outputted. Let's say you wanted to prepend a product colon string to each one of your product outputs. So what I can do here is I can say product colon and hit F5. That's not a good word to use because it's kind of getting confusing. Let me toss in some symbols, random stuff I wanted to add. There we go. That's better. But look at this. We changed the listing of our first product list, but not our second one. That's a consequence of code duplication. So what I want to do is I want to remove the duplicate code out of my program. There's a couple ways we can do this, actually. And one of them might actually demonstrate something really cool we can do with objects, and that is passing them as parameters. What I can do instead is add another method. I can say static void print product, and then I can just copy this code and paste it down here. And then I can replace both of my duplicated bits of code with print product. Now I hit F5, and the code is no longer duplicated. So that's really nice. We've solved the problem. But this solution comes at a cost. The cost of this conclusion, well, the cost of this solution is that we have increased the amount of methods that we have in our program class. Not only that, the logic right down here is very specific to a product class or a product object, but it's located very far away from the product definition. If we were to do all of our behavior inside of our class program up here, like what we've been doing so far in this class, then things will get very ugly very quickly. This will turn into a very, very, very large code file, and that's not good. So let's go back to what I said an object is. What is an object? Can anybody tell me what an object is? It's two things. Anyone? Hello? Right. We have data and behavior. So far we've seen an example of attaching data to an object with classes, such as name and price. We haven't seen an example of attaching behavior to an object. And this particular instance is a very, very good example of attaching, or of a good candidate of behavior to add to an object. So let's go ahead and do that. I want this print product method to exist on the product, not on the class program. And I hope everybody understands my reasoning for that. So what I'm going to do is I'm going to take this code, I'm going to copy it again, and I'm going to jump up here to the top on my product definition, and I'm going to add in a new member. The new member is going to be public void display, and I'm going to paste this code. And instead of doing product.name, I'm going to do this.name, and I'm going to leave it at that. A few things you might want to quickly note, although I'm not going to go talk about them too much at this very, very moment, is that there is no static modifier. That is actually significant. So if you notice that, then that's good, because that is something that's important. This method cannot be static because of the way I'm about to use it. So I now have attached a method to a class. We've already seen examples of using a method on a class. Like, for example, right here on line 27, we use the add method. The add method is a method that comes from the list class. So now that we've added a method to our own class, we can now use it very similarly to how we use the add method on our lists. So instead of saying print product, I can now say product.display. Same thing for down here. I can now say product.display. And I can remove my print product method because it's no longer used. So now when I hit F5, we get the exact same behavior. So what's going on here? So this is actually, this is very important to understand what's going on here. We have added a method to our class. By adding a method to our class, every object that we create of that class will have this method. So what is this? And when I say this, I'm literally referring to the this keyword. You'll notice that ReSharper is slightly graying it out because technically it isn't needed there, but I don't want to go into that right now. Well, we have an example right here of an instance method. An instance method is a method that can be invoked on a class by using, or an object by using the dot notation on an object. So I'm going to put a breakpoint right here. So we've already talked about all the breakpoints and stuff like that, and I'm going to hover over product. Look at product. Product is a variable of type product. It has a name and a price. So that should be what we expected, right? But now I'm going to hit F11, and I'm going to step into display. If I hover over the this keyword, it's the same object. So watch what happens when I loop over once. So now that I've looped over the for each loop again, the next product that we're looking at is product 2, which means that this object right here is product 2. And if I hit F11 and hover over this, we see that this is now product 2. So we see an example right here of an instance method. And when that instance method is invoked, we get the ability to reference his own data from within the instance methods by using the this keyword. The this keyword is actually redundant. We don't need it there. It's implicit. But I wanted to make it explicit here for the purposes of demonstration. I wanted to point that out because in some languages the this keyword is required, but not in C#. I could quite easily delete it and everything would be fine, but then it becomes a little bit more confusing as to where name comes from. By doing this dot name, it makes it more clear. Note that in actual programming I don't use the this keyword like this, but for the demonstration I will. What we have done is we have object-orientified our code slightly. So we have slightly used techniques out of the object-oriented paradigm to clean up our code. Not only have we removed duplication using object-oriented programming, our display behavior is now lying within our class product and it's usable everywhere in our program. We've also created a single list of product instead of having two lists of products. Or, sorry, a list of strings and a list of decimals. So how does object-oriented programming make our code easier to write? Well, it makes our code a lot more maintainable and extensible if you do it right. There's a lot of ways to do object-oriented programming wrong, and I guarantee you most of you guys out there who are new to object-oriented programming are going to do it wrong a lot. And that's just the way things are. I certainly did it wrong for a very, very long time, and still it's really all about design. It's really all about your creativity being applied to code. And there are many ways to do it. It's not set in stone. It's a very difficult concept to grasp. But it's important to practice it. So, let's see an example of this program being made more extensible and easier to maintain because I'm now using object-oriented programming. What if I decide that instead of having just a name and a price, I also wanted to have a public boolean is in stock. And then what I'm going to do is I'm going to change this right line to a right so it doesn't have a new line at the end of it. Then I'm going to say if is in stock console right line in stock, else console right line not in stock. By making that one change, I have affected every single object of product, which includes what's stored here in the list, meaning that I can now add is in stock to every object. Not only that, the display method now takes care of printing out whether or not it's in stock. So let's see an example of that. I want product 1 to be in stock, and I want product 2 to be out of stock, and I want product 3 to neither specify if he's in stock or out of stock, which is going to default to not in stock, by the way. But I wanted to demonstrate the default behavior. So, by changing our class slightly and adding a little bit more data within our program, we've vastly altered the behavior of our software. So, classes allow us to organize our code, because we can now write code and reuse it multiple times. Okay, so how is everybody feeling about the concept of object-oriented programming, as far as the concept of having a product class? Is everybody doing okay with that? Is anybody who's new to object-oriented programming doing okay with that? Alrighty. So let's talk a little bit about the syntax. A class can be defined almost anywhere in a code file. A class can be defined in a namespace, a class can be defined in another class. A class cannot, however, be defined, actually, that's the only two places you can define a class, in a namespace or in another class. But the reason I say it's almost everywhere is because the vast majority of your software is either in a namespace or another class. You cannot define a class in a method, so just keep that in mind. Alrighty. So right here we define a class. We know we're defining a class because we start off with the class keyword. That's how we tell C# we are about to define a class. And we give it a name. The name follows the same rules as every identifier in our program. So it follows the same rules as far as what you are allowed and not allowed to do as parameters and local variables and all that fun stuff. That being said, the convention of a class name follows the same naming conventions as method names, meaning you should always start with an uppercase, and if you wanted to delineate more words, then you would use camel casing from there on out. Okay, then we open up a block, and that's a very, very common theme in C# or in any curly brace language, really. So we open up a block, which means everything within this block is contained within this class. Inside of the class, we have what are called members. There are a few different kinds of members we can use. There are two examples of different kinds of members that we are looking at right now. These members are called fields, and what they do is they contain data. This member is called a method, which should sound familiar because we were creating methods on our program class last week and the week before. So we have an example of a class that has two kinds of members, fields and methods. Fields follow this format. To define a field, we start off with our modifiers. In this case, I've given it the public modifier. We'll talk about that in a moment. So we give it a modifier, we give it a type, and we give it a name. And we terminate with a semi. So this looks a lot like a variable definition, other than the fact that we have the public modifier. So that should look fairly familiar to people who have been working with variables for a while, which I hope should be pretty much all of you, at least as far as back in week 1 when we talked about them. And it behaves very similarly to a variable. The biggest thing to remember, though, about fields is that they are variables, but they only come into play when you instantiate a class. Which means that although technically, so this is kind of maybe a difficult concept for some people, but what we have right now is we have a variable name up here, but we actually have 3 instantiations of that variable. One used here on line 35, one on 41, and one on 53. These are, although they're technically the same field, they are not the same data. They're not the same data because its containing object is a different instantiation. So this is a field. Field starts with our modifiers, our data type, and our name. This is a method. A method starts off with our modifiers, our return type, our name, and our parameter list. The only difference between this method and the methods we've used before in this class is that this method does not have the static modifier. I'll talk about what static is very shortly. Again, when I say this method is not any different than the methods we've already been writing, that's true because look, it looks like a normal method except for one distinction. Whoops. I forgot to use the this dot here. And somebody asked me, do I ever use the this dot in actual production programming? And the answer is no, not for stuff like this. Occasionally it'll be necessary, depending on what you're doing, but I do not redundantly define it. What I want to show instead, though, as I'm demonstrating this code, is that the this keyword is available to you in any method that is not static inside of a class. This keyword refers to itself. When I say itself, I mean the object that this method is being run under the context of. So, like down here on line 49, we are running the display method underneath the context of the product variable. Meaning that the this up here is the exact same object as our product down here on line 49. Again, all we're doing here with this class definition is we are defining a blueprint that we can use over and over and over and over again within our software. And every time we instantiate a new one of these blueprints, we get a new object. And those objects, they're related in that they share the same class, but they're not related in that they contain their own data. So product 1 and product 2 contain their own data. But they're not, they are the same class. So remember, a class is a blueprint, or it's a template. It's like, you know, something that you can just stamp over and over and over and over again and use within your software. Alrighty, how's everyone doing with the syntax so far? Okay, I just want to remind everyone, when you go to practice this, you will be staring blankly at your screen for a large period of time. I actually, I had the fortune of learning a new, learning a new skill, or I guess trying to learn a new skill last year when I started drawing, and it made me realize, you know, how how you can sit there and watch an artist, draw everything, perfect, and that eventually all the lines come together and it's a complete image and it's wonderful, and you go to your own canvas and you're like, I can totally replicate that and everything, and you go there and you just sit there with your stylus and nothing comes out. I want to say that because I don't want people to get discouraged about object-oriented programming when they go to practice it. This is an entirely new way of thinking about software. I want to introduce 2 more bits of important syntax really quickly, and then we'll go on break. Now, the syntax I'm about to show is, again, it's another level up. It's another thing that we need to understand about classes to use them. Again, also, what I'm about to show you guys is going to make it clear why there are parentheses right here on line 34 and 40 and so on. So let's talk about another kind of member that we can place into a class. We've talked about adding fields into our classes, and we've talked about adding methods into our classes. But there are lots more things that we can put in our classes, and one of them is called a constructor. A constructor is a special method. All it is it's a special method that is invoked when you instantiate an object. The syntax for a constructor looks a little bit odd. We have our access modifier, but we do not have a type. Not only that, the name of the method happens to be the exact same name as the class. That is not by accident. A constructor will always have no return type, and its name will always be the same name as the enclosing type. But it can take parameters, and that's what makes constructors interesting. Because what I'm going to do is I'm going to initialize all of my fields using the parameters that were passed into my constructor. So let's go ahead and hit F5 and see what I just did. Well, I introduced a compiler error. Actually, I introduced 3 compiler errors specifically. So I said that a constructor is a special kind of method in that you don't have a return type and the name is the same as the class, but it has one more consequence. The consequence of a constructor is that if you define one, then that takes in parameters, you have to specify those parameters into the instantiation of the object. We see an example of that with our 3 errors that we have. We have product does not contain a constructor that takes 0 arguments. The reason it's saying that is because we created our own constructor that require 3 arguments to be passed into it. So what was the purpose of what I just did? Well, the biggest thing that I just did was I just cleaned up the code significantly. Watch what happens as I rewrite this code to be valid. So now when I hit F5, we get the exact same output that we got before. What I did was I introduced a constructor. A constructor is a special kind of method. If you define a constructor that takes parameters, you must pass those arguments in to the class when you instantiate it. That is why whenever we instantiate a class, we must provide parentheses, because technically, every time we instantiate a class, we're invoking a method. And whenever you invoke a method, you need to supply parameters, even if there aren't any parameters to supply. Like for example, on line 50, we still have to invoke this method, we still have to provide these the parameter or the argument list, although there aren't any parameters in this method, so our argument list is empty. That's why we have to have those empty parentheses when we instantiate a list. But if we create a class that has a constructor that takes in argument or parameters, then we are forced to actually pass data in to that class when we create it. So what does this constructor do? Well, this constructor could technically do anything. Again, a constructor is simply a special method. And a constructor can do anything that a method can do. But the most common thing that you would do in a constructor is you would initialize your data. In this case, I am initializing 3 fields using the 3 parameters that were passed into this method. So, how's everyone doing? And don't be afraid to say that this is absolutely terrifying. Well, at least one person's doing good. So again, up here on line 39, when we instantiate a list, we always have to invoke the constructor. The constructor is a special method that always has to be invoked. But not all constructors take parameters, just like not all methods take parameters. So on line 39, the constructor for list does not take any parameters. And because it doesn't, we provide empty parentheses that say that we are invoking a method, but that method takes in no arguments. However, on line 41, because the constructor is defined and because the constructor does require parameters, we have to provide those those arguments using the argument list. So again, it's very object-oriented programming is a completely new way of thinking. It's a paradigm. It's a way of approaching a problem. And the best way to approach learning object-oriented programming is to write code out. And then, after you practice it a few times, just practice. Just write this code out on the screen. I highly encourage people to download this video afterwards and write this code out, because there's a lot of new syntax to talk about. The more you do that, the more instances you will find while writing your software where you think, should I use a class here? Or should I use a constructor here? Does this class need a new method? And so on and so on and so on. And you'll try it out and you'll experiment. And a lot of times you'll fail miserably and your code will break and the world will end. But there will be times where you say, I need a class here, and all of a sudden your program just becomes 10 times cleaner. Or you'll say, I want to move this bit of functionality into a method. I don't know exactly why, but I'm going to do it. And you'll do it that one time, and all of a sudden your code will be 10% cleaner. And those reinforcing experiences will just collect in the back of your mind while you program, and eventually you'll start thinking in terms of object-oriented programming. But it's not going to come very quickly, and it's not something that I can just make everybody understand by explaining it. I can only show people the tools, but to use the tools, it necessitates people to practice and experiment and fail and succeed a few times, because a success will help significantly in the understanding. So let's do one more example and then we'll go on break. What I'm going to do is I am going to toss, am I? Nah. Let's just leave it at this, and I'm going to make it so the user can input however many products that he wants, and then I'm going to display each one of the products. So I'm going to say bool is entering product equals true. And remember, each one of these guys up here, line 9, 10, and 11, these are fields. I've said the word variable a couple times because it's a very similar concept, but it's important to understand that these are fields because they are a member of a class. Because there's not just one name. In fact, right now in this program, because I don't instantiate a single product, there are 0 names anywhere in this program. But if I instantiate a product, I get a name because it has a name in the definition. If I instantiate a second product, I have another name. And if I instantiate a third product, I have a third name, and so on and so on. That's why this is called a field, because it isn't a variable, although it behaves like one, because a variable is defined once, and that is the variable, and there's never any more of them. With a field is attached to a class, and you get a new instance of that field every time you instantiate the class. All right, let's go ahead and finish this example real fast. So I'm going to say something like string name, decimal price, bool in stock, console right line, enter product name, blank to stop. How about, or enter to stop, that'd probably look nicer. And then I don't want to write line, I want to write. Actually, I want to invert this. I like that more. Price equals, I'm not going to do any, I hope you guys are used to this right now. I'm not going to do any sort of decimal validation here. Although you would definitely want to if this were a application or real application. Console write. Oops. Actually, I'm not going to even do that. I'm going to consolidate this onto a single line because at this point you guys should be used to the in stock equals console read line equals 1. Products.add new product name price is in stock. Then I'm going to say console write line done gathering products. Printing. Oops, I keep on hitting that key for some reason. I don't know why. Okay. So here's an example of a program that allows the user to enter as many products as they want. The reason I wanted to print this out, I wanted to type this out before we went on break for 2 reasons. The first one is I wanted to show an example of instantiating an object but not assigning it directly to a variable. Instead, what I'm doing is I'm instantiating an object and passing it directly into a method. The next thing I wanted to demonstrate is we had a question, how would you have a constructor that required information and then have that information be provided by the user? Well, the answer is you would collect the information beforehand, and then once you had all of the information you needed, you would then instantiate the object and pass in that data into the constructor. So to prove that this works, okay. So again, this program is kind of a combination of everything that we've learned so far. So we have an example of variables up here. We have a while loop. We have console input and output, conditionals, parsing, technically another conditional operator, object instantiation, and a for each loop. So by combining all of those things together, we are able to write this program. Okay, so I'm going to go ahead and go on break and let this kind of seep into everybody's brains. And then when we get back, there are a few more things we need to talk about. We need to first talk about accessibility. What does this public mean? The next thing we need to talk about are properties, or another way to say that is we need to safeguard our data a little bit more than we're doing right now. And then the final thing we're going to be talking about is what exactly is this static and why do we need it on main but we don't need it on display? And we're back. So just a quick recap, we have introduced classes today. Classes are a means of creating objects. We've already been using classes within our software, particularly the list class, which we've used to create lists of things. But in this case, we defined our own class called product, and what it allowed us to do is allowed us to encapsulate data and functionality that is specific to a user-defined class within our program, and allowed us to reuse that behavior and functionality within the rest of our software. So I'm going to talk about another kind of member. The use of this type of member will look very strange to people. And yeah. This is going to be a hard thing to justify. This is one of those things that is just how you write code. And what I mean by that is we have an example right up here of 3 public fields. Public fields are bad. They're bad because they are publicly exposing the data of our class to everybody. In this particular program, that is not as important. We don't really care about the fact we're publicly exposing this data. But in most software, you do. And the reason is that you really want to have a clear definition of what this class does, and you don't want anybody to muck around with his internals. So you want a way to safeguard this data. Right now, I am able to do something like this. So I'm going to remove this example and simplify the code a little bit so I can talk about access modifiers and accessibility and properties. So if I go ahead and create a product called product1 and I instantiate it, give it a name of product1, a price of 23.4M, and a is in stock, set it to true. What I can do is I can reach all the way into this product and muck around with his internals. And there is nothing stopping me. Or what am I doing? I should just do product1.display. So I am allowed to modify all of his data. And the reason I'm allowed to modify his data is because these are public fields. The public access modifier is a way of describing the visibility of a member. Now, what's a member? Again, a member is anything that goes into a class. For example, these three fields are three members. This constructor is a member. This method is a member. And because all of these members are public, they're exposed. So I don't want name and is in stock to be publicly accessible. The reason I don't want that is because it'll allow me to do something like name equals null, or name equals not a valid product name, which in this program is not a valid product name. What I need to do is I need to make my members private. And we can do that by changing this public word into the private word. Now, by changing my access modifiers on my fields from public to private, I have done two things. First of all, I've actually changed how these should be named. This naming convention is no longer appropriate. And the second thing that's happened is I can no longer reach into his internals. I can no longer access his data because name is now a private member and it's not exposed by the class. If I were to try to compile this program, I get name is inaccessible due to its protection level, because I've now made name private. So that's nice. But let's fix the first problem first. The first problem is that this naming convention is no longer appropriate. Sorry, I glanced over into chat. That was a bad idea. This naming convention is no longer appropriate. When you have private fields, they are named differently than when you have public fields. What you should always do with private fields is you have two options. Either name them as you would name a local variable with camel casing starting with the lowercase. Do this. So let me go ahead and fix the rest of my code because I've now, by changing the names, I've now broken everything. So this is your first option. And this is a, whoops. This is your first option, but it's not what I typically do, but it's something you'll see used often. It's perfectly valid. It's technically within the C# naming convention guidelines, but I generally, this is the one point of contention I have with those C# conventions, in that I prefix my private fields with an underscore. I'm going to leave one of them without an underscore, and then I'm going to leave both of them with an underscore. If you want to name your private fields without a prefix, so you just want to name them camel casing starting with the lowercase, such as is in stock with the lowercase I, instead of underscore is in stock, then notice what's happened here on the constructor. Can anybody tell me why ReSharper has made this instance of this redundant, but this instance of this not redundant? So why is this kind of grayed out, but this isn't? Can anybody guess? Well, the answer is, what I've done here is, this is the reason why I like having my private fields be prefixed with an underscore. Because this dot in here is now required. Look at this. The parameter name is in stock is the exact same as the private boolean is in stock. And because is in stock is closer in scope, it is referring to itself. If you plan on not using underscores with your private fields, then be sure to always prefix your private fields with this dot. Otherwise, you will run into a situation where you will be doing something like this, where we're assigning a variable to itself. Now, I'm not going to tell people what naming conventions to use, other than the basic ones of class names and method names, and public members should all be named the exact same way as the C# guidelines say. As far as private members, I'm not going to say anybody needs to do one thing or another. I was just showing that you will see people have this format and you will see people have this format. Some people have an M underscore. Some people just have the underscore and some people don't have the underscore. I just wanted to point that out. So does everybody understand, at least this is sort of an ancillary concern to private members as far as fields go, in that their naming convention differs from public members? But does everybody at least understand the concept of the fact that I have now made these members inaccessible? So, again, by making these members private, the only code that can access these members is code that appears within this class definition. Anything outside of this class definition is not allowed to access this data, which is a good thing. Okay, so we've made our data private, but we've introduced a problem. The problem is we can no longer change our data. In fact, we can't even read our data. The data is now completely encapsulated within the class of product, which is sometimes exactly what you want to do, but sometimes it isn't. And when it isn't, you never want to make your fields public. You have two options at this point. The simplest option, and the option you will see most common in many programming languages, is creating accessor methods. So let's say I wanted to have my name, I wanted to be able to retrieve the name from a product, but I don't want to be able to muck around with the data of name. I can make a method, public string getName, that returns name. By doing this, I can now get my name. So I can say console writeline product1.getName. The getName method is a way for me to expose private data publicly. So what about setting data? Well, setting data gets more complex because a class should never become invalid. You should always make sure that your class contains valid data, even if those checks are simply sanity checks. What I mean by a sanity check is a check to make sure that you aren't putting your code into an invalid state that should never ever happen. Because if there's one universal truth about programming, is that stuff that never ever ever should happen happens all the time. So what I'm going to do is I'm going to create another accessor, but this accessor is going to return void, and it's going to be called setName. Okay, so now I can get the name and I can set the name without having public fields. So let's see what that looks like. So I can now say product1.setName and product1.getName, and I can hit F5 and the code works. Now a lot of you guys might be saying, okay, well, I kind of understand methods. I kind of see what you're doing here. You totally forgot to put the this dot in when you said you were always going to, so you fail, Nelson. But I see what you're doing here with the methods. You are wrapping around your private members with something that's public so that you can expose them indirectly. But why would you want to do that? Well, the biggest reason that you want to do this is for future extensibility, insofar as the ability for you to add additional logic into your getters and setters. So in the public string getName, we happen to just be returning a field, and that's it. But we're not limited to just returning a field. This is a fully fledged method. We can put whatever logic we want into this. Let's say that down the road, we changed the way that our name is stored. Because this is a method, we can now change the logic that retrieves the name without having to update all of the instances of other bits of code using that field or that data. The second thing is, our setName method can now have validation within it. I can now say, if string.is null or whitespace name, throw new argument null exception name. So, I have just added a safeguard, a sanity check, to ensure that my name can never be null or blank. So watch what happens. What do you guys think is going to happen if I do product1.setName and then put in a blank string? What's going to happen here? Well, I don't get any guess. Oh, there we go. We get one guess. Two guesses. Sweet. We get an exception. Value cannot be null. So what we've done is we've added a sanity check and some bits of validation into our code to ensure that our product can never be placed into an invalid state. So that's pretty cool. How are people feeling about getters and setters? There's one more thing that I want to introduce as far as getters. I want to create public string get display string. Get display string is going to return this name is this price. So this is an example of another bit of code. It actually computes the value of the data it returns, which is really powerful. Okay, so is everyone doing good so far? Because I'm about to blow your guys' minds again. This pattern is so common in all programming languages. You do this so often, so incredibly, ridiculously, insanely often, that the developers of the C# programming language actually invented new syntax for us to write code that falls under the category of a getter or a setter. Right now, our code doesn't necessarily look that user-friendly, because I have to say product1.setName, console write line, product1.getName. It's not very user-friendly. We're just invoking methods on it. This is the kind of code that you have to just simply get used to if you're working with C++ or Java. But in C#, there is a better way. Like I've said before, we have a bunch of different kinds of members we can place into classes. We have an example of fields, constructors, and methods. There's a couple more, and the one I want to talk about is called a property. A property is a crazy bit of syntax. What makes this a property is it starts with its modifiers. In this case, we're marking this property as public. It has a type, just like a field does, and a local variable, and it has a name. The names follow the same conventions as method names, except method names should contain a verb, whereas properties should simply be a noun. Just like how our variables and fields are. Then we open up curly braces, and that's where things get kind of freaky. Think of a property as a collection of two methods. It's a shorthand syntax for creating two methods. One is a getter, and one is a setter. Right now, our getter and setter do the exact same thing as the getName method and the setName method. They have the same code in them. When we have a getter, although we don't have any access modifiers on the getter, we don't have any type on the getter, and we don't have an identifier on the getter, this is a method. This method has to return data that is of the same type as the type of the property. Then we have a setter. Again, no access modifiers, no return type, no parameters, no name. It's just the keyword set followed by a block of code. A setter will always return null, or sorry, not null, void. A setter returns nothing. The one special thing about a setter is that it has a very special keyword you can use called value. So where does this value come from? Well, it comes from the way in which we use properties. I'm going to leave getName and setName up here for now, but I'm going to rewrite my code that uses getName and setName, or I'll just do another example of it. I'm going to say product1.name equals, hey there, console write line product1.name. Okay, so what we've just done is we've created a property, and this property is something that we can use in both the context of assignment and retrieval. It looks, it smells, and it behaves just like a public field, but it's actually a method behind the scenes. So, although we're saying product1.name equals blah, we're actually invoking a method. And that method is defined right here in this special syntax. Whatever we assign the method, this name property to, gets turned into the value variable. And I can prove that to you guys. I can go ahead and I can set a breakpoint right here, and hopefully, no. Give me 1 second. To step into properties with the debugger, you actually have to enable a thing that I completely forgot what it's called. I think you have to, there we go, step over properties and operators. I'm going to uncheck that so I can prove to you guys that when I run product1.name equals hey there, and I hit step in, we are now executing this setter. And if I hover over the value keyword, the value keyword is the value that was assigned to this property. See, if I jump back in my call stack, hey there is the value we're assigning name to, which means that when the property gets invoked, the value keyword has that value in it. All this code is doing is that it's making sure that our string is neither null or white space, and then it's assigning our local field to that value. I can go ahead and step in one more time. So I just stepped in on this line right here, the access of product1.name. Notice how it's now executing the getter. And all the getter does is it returns name. So let's do one more example of a property. And properties are not specific to C#, but they're one of the more, C# is one of the major few languages that support this. C++ doesn't support properties, Java doesn't support properties. You can, once you start getting into dynamic languages like Ruby or JavaScript or PHP, it becomes a little bit more complex to describe properties because they have other features that are similar. So yeah, let's do one more property. So remember my getDisplayString method? Does everybody kind of get what's going on here with the string getDisplayString? Where we're just taking some data, concatenating it together and returning it. So think of this as like a computation, like a really expensive, super complex computation. Or no, it's not complex because of it, or expensive, because if it was expensive we wouldn't make it into a property. So this is a super inexpensive computation that we're performing. What I'm going to do is, instead of getDisplayString, I'm going to make a property, public string displayString, that has a getter that returns this name, this price. So I have now made a property with only a getter, and that's completely valid, and that's very common. So this property has a getter but no setter, so we can't assign data to my display string, but I can retrieve data out of it. So now I'll have two examples of getDisplayString. So I can say console write line. I can either do product1.getDisplayString. .getDisplayString will simply invoke our getDisplayString method that we have here defined on line 54. Or I could do console write line product1.displayString. Now displayString is a property with a getter on it. And because it has a getter on it, I can access it in syntax that looks very similar to a variable. But it's not a variable. It's actually a method. Remember, a property is an abstraction over the concept of a method. All it does is it changes the way that we invoke the thing. The thing being the method or the property. Okay, so how's everyone doing? Somebody asks that what happens if we assign something to getDisplayString? We get an error. The error we get is the property displayString has no setter. There's nothing for the compiler to do. I'm not sure about how this is nightmarish for external users. Properties actually make things a lot cleaner for external users, because instead of having to write code like this, we can simply say product1.name. Yeah, properties have one or two methods inside of it. They either have a getter or a setter, or they have a getter and a setter. And yes, you can make set-only properties. I don't think I've ever made a property that's set-only, but it's possible. I don't know why you would do that, but you can. Can we use other methods inside a property other than get and set? No. A property may only have a getter or a setter or both. It cannot have anything else. For setting, is it better to use methods? It completely depends. Very commonly, I don't use public setters on properties very often. That's just how my style has evolved myself. I will very commonly have methods instead of setters. I'll have public getters, but I won't have public setters. And that's a stylistic thing that I do. I find that it's a little bit more explicit when you have a method, and it makes a little bit more sense to me. Are there any good uses of public fields? Not any, actually. I mean, making statements like that in regards to programming is very difficult for me to do, but to be honest, I don't see any reason to use a public field. It just doesn't work. Okay. There's one more thing about properties. Or actually, let's do 2 more things about properties and then move on to static. So if you guys are getting overwhelmed right now, then just ignore what I'm going to talk about with properties because it's a little bit more advanced, but it's also important. Just save your mental energy for staticness. But there are 2 quick things I want to wrap up about properties. The first thing is you can give your getter or your setter accessibility, meaning I can define a public getter and a private setter. If I go down here, we now have an error because its set accessor is inaccessible. Now, why would you do this? Well, I'll show you why in one quick second. I'll show you why after you guys tell me what exactly is wrong with this code so far. There's a very big problem with the code. Look closely at the constructor. Line 34. We are allowing the name to be assigned directly to the parameter that was passed in without any sort of validation. If you use properties in order to do validation, which is very common, then what you want to do is you want to assign the property, not the field, to the value so that whatever was passed into the product constructor gets validated by our property. So I wanted to point that out real fast. Okay, so there's one more thing that I want to describe about properties, and that is it is very common in programming or in C#. I'm going to go ahead and clean up my product class a little bit. It's getting a little bit too large for me. It's very common in programming that we want to be able to expose data publicly, but we only want to be able to set that data internally. So it's very common to say, okay, I want name to be exposed publicly, but I don't want it to be set publicly. Or it's also common within programming to say, I really, really do want people to be able to change the value of name, but I don't want to make it a field because that breaks potential flexibility down the road with binary compatibility. Because this is so common, so I'm going to write a that and that. Okay, so I now have a name property with a public getter that returns name and a private setter that sets name to value. Doesn't do anything special, doesn't do any validation whatsoever. But you'll want to do this a lot. It'll happen. There's a better way to write this code. I'm going to write a price property, but watch what I'm going to do. I'm going to delete the field. Then I'm going to say public decimal price get private set So what is going on right now? This syntax is new in C# 3. It's called the automatic property. An automatic property allows us to succinctly define a property that has no validation and it contains a backing field. But it does give us a lot of flexibility. For example, we can set the accessibility of our automatic setter or our automatic getter. So, what do we have here? We have an automatic property. All this does, this syntax right here, it creates a property and a field. And then it wraps that field within this property using syntax very similar to what we have with name. Notice how I do not have a price field. Although I do have a name field because my name property is explicit. In this case, I don't have a price field. That field is being generated magically by the compiler. I just wanted to introduce this syntax to people because you will see people using it. It's a very common bit of syntax. So I wanted to point that out for everyone. Alrighty, so how's everyone doing? I wouldn't use this in front of your members. I was just doing that earlier because to make things more explicit, it's actually implied. You can always pretend that if there isn't anything before, then you can pretend that it's this. So it's implicit. Can you still validate with an automatic property? No. You cannot put any logic into an automatic property. Although that's not technically true. You can go download PostSharp and throw on an aspect, but that's way beyond the scope. No semicolon after public decimal price. No. There is no semicolon after this. Just like there's no semicolon after properties, like normal properties, and there aren't any semicolons after constructors or methods. Automatic properties, just to restrict whether set or get is available, that's my most common use case of them. The second use case of an automatic property is when you feel like, hey, I really do want a public field. I know the consequences of it, but I really, really, really do want it for some reason. Just smack yourself in the face and use an automatic property instead. The reasons for doing this are slightly esoteric, but they are documented, particularly when it comes to what's called binary compatibility. If you find yourself in a situation where you absolutely want a public field, just write a public automatic property with a public getter and setter instead. The difference between my name property and my price property is that my name property, I explicitly wrote both the backing field called name, the getter, which returns name, and the setter, which sets name. With my automatic property on line 18, I had the compiler write all of that for me. This property requires a backing field and two methods, whereas this property, because I used the special syntax called automatic properties, has the C# compiler write it all for me. what field will Price use? The field that Price is going to use is generated by the compiler. It's actually completely inaccessible. See, Price is not a field. It's an automatic property. The C# compiler generates a backing field for me. I wonder if I can coax the debugger to show me that backing field. Oh, I probably could. Or, you know what I could do? I could do. Oh, come on. Oh, come on. Seriously, guy. There we go. This is the name of the field that the C# compiled. Or, the C# compiled. That's probably the stupidest sentence I've said all class. This is the field that the C# compiler generated for us. It did it magically. It's not accessible. In fact, look at the name of the field that the C# compiler made. Notice how it has those brackets. That actually is something that's called an unspeakable name. Whenever the C# compiler generates something for us, it usually makes it unspeakable. Unspeakable means that it's impossible for C# code to reference it. So there is absolutely no way to directly reference this backing field, ever. Because this is a valid name in the CLR, but it's not a valid name in C#, so there's no way for my code to ever possibly conflict with it. That's why it's named that way. But again, this is what the C# compiler magically created for us because we made this decimal. Now if I went ahead and I turned name into an automatic property and compiled and ran this little bit of code again, now see how we have two backing fields that were generated for us by the compiler. Alrighty, so how's everybody feeling about automatic properties? I know they might seem a little bit silly to use. They might seem like, why would you do this instead of making a public field? There is a documented argument to always use properties. I'm not going to get into it yet right now, though. You can look it up online. Okay, so let's take a step back and talk about the last thing that I want to talk about today, and that is the concept of staticness. What am I going to do? I'm going to go ahead and make product as simple as possible. So I'm going to create a public static string name with a public getter and a public setter, public static decimal price with a public getter and public setter, and whoops, why am I making them static? Derp. And I'm just going to leave it at that. And then I'm going to create two products. Why am I not copying and pasting this code? Okay, so I have two products. Right now, all the members inside of product are instance members, meaning that these members get instantiated along with the objects. So we already have talked about how the fact that this name property is different from this name property. They contain two different bits of data. Well, that's because they're instance. The same goes for if I did public void display and said console writeLine name plus price. This is an instance method, meaning this method is owned by both of the objects of the type that I'm creating. So let's talk about static. Static is the antonym of instance. So if instance means that this method is carried along with all of my products, the word static is the opposite of that. Static means that there's only one of the things that we create that is not carried along with every individual instantiation of an object. So if I made a public static void doThings method, can anybody tell me how I can invoke this method? How do I invoke the doThings method? Right. We can't invoke this method by just typing in doThings. That's impossible. We can't do that because doThings exists in another class. We can't say product1.doThings. We can't do that either. The reason we can't do it is because I define static as the opposite of instance, which means that the doThings method is not carried around with every object that's instantiated. So, what do we have to do instead? Well, we reference the class directly by typing in product using the same casing as the class, and then we do doThings. So, a static member is a member that is owned by the class and not by the objects that are instantiated from the class. So that's why main is static. I'm sure a lot of people may have been wondering during this class, as I've been talking about what classes are, what object-oriented programming is, what members are and methods are, and so on. You might be wondering, well, okay, so I get that you need to instantiate a product in order to use a display method, because display is an instance method, right? We have to instantiate a product in order to invoke display. So does that mean that the operating system instantiates a class to invoke main? The answer is no, because main is static. Main always has to be static. In fact, I can prove that program is never instantiated by creating a constructor for program. And hitting F5. Program is never instantiated. It's never instantiated because main has to be static. And when you invoke a static method, you do not need an instantiation of that object. Instead, you reference that class directly and you invoke that member. So this method is not carried along with product. Okay, so let's do a little exercise. I'm going to remove the invocations to display down there. What do you guys think the output of this program is going to be? Right, so it's going to be count 1, count 2 is count as 1. Then what happens on the second invocation? So think about this. The second invocation is going to increment both count1 and count2. But watch what happens. Let me format this a little bit better so it's easier to see. Okay, so on the first instantiation of product on line 34, we have count1 equals 1 and count2 equals 1. That's because we incremented both count1 and count2. But look what happens on line 38 when we instantiate the second product. Count1 is still 1, but count2 becomes 2. So why is that? If I open up my debugger and inspect product 1 and product 2, you'll notice they both have a count1 field. So count1 is 1 on product 2, count1 is 1. That's because if I step through the invocation of the constructor, count1 starts off at 0 and then gets incremented. Count2 starts off at 0 and then gets incremented. But the second time that we invoke the product constructor, count1 is still 0 and then gets incremented, but count2 is 1 and then gets incremented. That's because both of these objects, product 1 and product 2, own a count1. They have two different count1s that have different values. But because count2 is static, it is shared between all of the product instantiations. Meaning if I were to introduce a third product, count2 would eventually become 3. That's because, again, count2 is data that is not instantiated by creating an object. It is always present. And there's only, there can only be one. So think of a static field or a static member as the Highlander. Is there any additional overload for using static? No, not particularly, or not anything that's worth thinking about. So I really wanted people to understand the static keyword mainly so that you can hopefully start to understand why the main method is static, whereas these methods are not static. It's also why when you're in a static context, you can only access other static data. What do I mean by that? Well, I'm going to write a public static void do things method. What happens if I try to do this? When you're in a static context, meaning when you're inside of a static method or a static property, which technically are methods, then you are not allowed to access anything that's outside of that static context. Remember, name is an instance field, or sorry, an instance property, meaning that name is instantiated or created for every instantiation of an object. Which means that when we're in a static context, we can't access that data because we don't know what product we're talking about. We have no idea what product we're talking about. Which one of these three products should this name be referencing? See, if I were to not even instantiate any products, maybe this would make more sense because look at that. I'm not even instantiating a single product. How can do things, because it's static, know what the data name is? It doesn't, it gets confused. Well, it doesn't get confused. It tells you you are doing something wrong and there's no way to compile this code. That's why if we try to make another method, if I tried to say void stuff and things inside of our program class and I forget to say static, That's why this doesn't work. When we're in a static method, we can only access static data. So now it works. Now that doesn't mean that we can't pass something into a static method. For example, I can have doThings take in a product called product, and then I can say, hey, and then I can say product.display, and then I can instantiate a product. And then I can pass it in to doThings. I mean, that's valid. The reason this is valid is because I'm not invoking or I am actually invoking a method on an object. I'm not just trying to invoke a method that isn't attached to anything. Think of this display method as being attached to this product. So, have we used static methods? And the answer is yes, we have. We've used quite a few of them. Console.readKey is a static method. Notice we don't have to instantiate a console to use it. But list of string stuff, the add method on a list is an instance method. We cannot say list of string dot add, whoa. This makes no sense. It makes no sense because add is not a static method, because even if it were, what list would it be adding it to? We need to know what list we're adding it to, so therefore add's an instance method, and because it's an instance method, we have to have an object of that instance or of that type to invoke it. So how's everybody doing with staticness? Okay. As far as design, static data causes issues in code. Whenever you have static data, you are making your code less flexible because there can only ever be one of those bits of data. That being said, unfortunately at this point, it's probably going to be necessary for a lot of people to work with static data simply because the alternatives tend to introduce some concepts that might be a little bit complex. And just getting used to object-oriented programming is more important than trying to be completely pure. Good for high score. Yeah, I wouldn't do it, but I would. That would be something that a person I could see. I could see a person doing that. So it's definitely complex as far as why you wouldn't want to use static data. To sum it up the best I can, again, is the more static data you use, the less flexible your program becomes because there can only ever be one, and it becomes very difficult for you to reason about your code. Static is essentially just static data is global data. It's shared data. It causes maintenance issues. Static methods, if you can get, yeah, I don't really see any problems with static methods, but static data is really what you need to take care or think about. Okay, so I think that just about wraps everything up for the day. We've been going for about an hour longer than I wanted to, although I knew this would happen. I'm going to go ahead and pause the video and step outside, and then we will go ahead and get going with some questions. Alrighty, and we're back. So, today we covered quite a few really important concepts. We talked about creating our own classes, what classes are and how to instantiate objects. We talked about members of classes. We included discussions about fields, properties, constructors, and methods. We talked about automatic properties. We talked about static versus non-static members and what the differences are between them. And that's really a lot of terminology and a lot of stuff to take in. And I want to point out that the object-oriented nature of C# does not end there, not even close. In C# we have a lot more power and flexibility when it comes to things like interfaces and overridable methods and inheritance. And we didn't get the chance to talk about any of that stuff, and that's actually intentional. It would be really good to see people try to take what they saw here and start applying it to their own applications. I think it's important to set expectations about how people will learn object-oriented design, in that it will be a very difficult process that will take a lot of practice, but I don't want people just to give up. I see a lot of people who are new to object-oriented design, they either use classes too sparingly, or they use way too many and the code becomes way too complex. The best way to learn it is to focus on creating an application that is larger in scope than what you guys have been used to creating, and see if you can introduce some of these concepts into it and work with it and see if your code becomes more clear. Because ultimately the whole purpose of the object-oriented paradigm is to make code more clear and easier to use and easier to write. That's not always going to be the case. Like I said, it's a very long process to get comfortable with this sort of stuff. You have to really solidify an intuition. A lot of the object-oriented design decisions that I make, even in my own production code, can be hard to justify to people, simply because it's an intuition. Obviously, when you do write production code, you should be able to justify virtually every line of it, but what I mean, though, is that everybody approaches problems differently, and when you have a tool as versatile as object-oriented programming, people will come up with different solutions to solve the same problems, and some may be better than others, some may be as good as others. There is no black and white when it comes to designing the architecture of a program when using object-oriented programming. So, I think that just about wraps up our C# 101 class. We went over the basics of the language and the most common things that you will see in C# code. From this point, it would be possible for people to start taking their knowledge of C# and applying it to environments that are more complex and more rewarding than a simple console application. Again, I didn't want to start an introduction to programming class using something like ASP.NET or Unity, because at that point you would be learning two things at once. You'd be learning the syntax of the language and the specific idiosyncrasies of those platforms. So I hope now people are at least comfortable with the language enough to approach learning a platform such as ASP.NET or Unity and be able to follow along with that to create web applications or games or whatever it is that you guys want to create. C# is a very powerful language. It runs pretty much everywhere. Anything from a microprocessor to running data centers in the cloud. And it's a very versatile language that's used in so many different contexts. So at this point, it would be good for people to start exploring the different contexts that you can use C# with. Because no matter if you're writing Unity or embedded code or websites or applications or games or anything, it all boils down to the syntax that we've talked about in this class. It all boils down to methods and classes and properties and expressions and statements and ifs or conditionals and switches and looping and all that fun stuff. It really all boils down to that. That's the atomic unit of programming, I guess you could say. So I hope everyone enjoyed the class. We will be doing a free class soon, hopefully on Unity, in the near future, for people who want to hop into that. So with that, I think
that about wraps everything up. So I hope everyone learned a lot and had some fun, and I'll see all you future people later. Goodbye.